Um, Welcome to the PIBBSS Symposium for this year 2025. This time it's Abhinav Singh presenting today on security testing for multi-agent systems. For anyone who, well, we all know here, if you have questions, feel free to raise your hand in the middle of the talk as well, or you can use the Q&A option at the bottom. And whenever you're ready, Abhinav, feel free to begin.
Yeah. All right. Thank you so much, Sahil. I'll get started then. Hello, everyone who has joined in. Thanks for being part of the group. And yeah, I want to begin by thanking PIBBSS for the great opportunity to spend time and research on multi-agent security. It has been fun 3 months, and collaborating with the group, working with everyone has been quite a lot of fun and a learning experience for me. So I'll discuss a little bit about my project, some of the findings that I had. I'll also cover a little bit about the demo of the dashboard or the solution that I have built up and how I plan on kind of extending it to the next level. So my focus area for last 3 months has been to look at different multi-agent security frameworks and kind of come up with an approach by which we can perform some kind of security testing that can help us understand how certain weaknesses or vulnerabilities or compromises in these multi-agent frameworks could potentially result into I wouldn't say misaligned, but I would say that how it can potentially result into behaviors that might be deviating from the original intention of the application itself. So a little bit of an introduction. This project investigates how one single compromised agent within a group of multi-agent systems can escalate privileges and move laterally through trust relationships, potentially compromising the entire system. So that has been the focus area. Um, it kind of gets into the assumption that you already have a multi-agent system built up for, let's say, certain activities or part of a software or part of an execution suite, primarily thinking of it from an enterprise application. Some of the common examples could be things like, let's say, there is an enterprise that is trying to build up a um, shopping assistant agent for its consumers. So the typical flow of that would look something like, let's say it is a multi-agent system. Probably there would be one agent that is responsible for getting the requirements from the user about what the user is looking to purchase or buy and things like that. Maybe, let's say, new pair of shoes with best price, best discounts available with certain color options and so on. So that kind of becomes the part of the uh, the research agent component in this whole scenario. Along with that, there could be some additional agents as well. For example, there could be one that would be responsible for, let's say, processing the payment once the right product has been found on the internet. So that would become another part of that system. So the moment we have like more than one agents in that system, that's when we kind of call it multi-agent. Now, the whole project goes into the idea that, let's say, one of the agents in this whole system has a potential security misconfiguration or security weakness that probably an external attacker might be able to compromise. And they have a foothold on one of the lower privileged agents in the system. And how can they use this as a pivot point to further infiltrate into the system, understand the system's architecture, and kind of perform a lateral movement that allows them to perform actions which are beyond their existing privileges or the privileges that have been given to the agent that has been compromised. So that's what the goal of the project is. We use red team toggles. What it basically means is we have defined certain scenarios or certain compromise situations based on different properties of multi-agent systems or different frameworks that are used to build up these multi-agent systems. it kind of goes ahead and executes those red team toggles to see how many of them are successful versus failed. A little bit of an overview. So the purpose of the project has been to identify security vulnerabilities in multi-agent systems through automated testing. The approach that I have used is to build up a common framework that helps me set up an example bunch of, not just one, but different multi-agent systems for different tasks using different available frameworks that we have. So think of it like I have a system which kind of like spins up the same type of agents using different frameworks that are available. I'll talk a little bit in my slides as to why I wanted to do it. This was primarily to make sure that I have a common ground to evaluate all the results, look at different vulnerability types, and so on. So I have built it up as microservice architectures. So each of the components in my system are kind of like individual microservices. They have all the APIs defined for it. And for all the conversations, each microservice will call an API. It will talk with the other microservice, get all the information, update the database, and so on. I'll talk a little bit about the architecture as well in the later slides. And then finally, results. There have been some findings which I have talked about in when we had our retreat as well, the closing one. I'll talk a little bit about as well on what the outcome was, how I reached out to some of these multi-agent security frameworks, what their responses have been, and so on. So the approach that I've taken is to build up a common framework that spins up the multi-agent services across 3 open source mass frameworks. So the 3 most common multi-agent frameworks that I have tested this application on, or tested this whole idea on, LangGraph, AutoGen, and Creo AI. So as I mentioned before, the goal has been to make sure that I'm able to replicate the same set of multi-agents across these 3 multi-agent building frameworks. This will allow me to be very certain that I'm spinning up the same scenario, creating the same set of agents with same set of permissions across each of them. And then I'm able to run my test cases. Some of the test cases have been specific to the frameworks. Some of the test cases have been generic, which would work across all 3 of them. So as I get onto the later slides, I'll show what are some of the specific testing frameworks which were specifically that I specifically created for LangGraph because of the way it builds up the multi-agent systems versus what are some of the other specific tests that have been built up for something like AutoGen. So that's kind of an overall approach with which I went into tackling this project. Now, before I get in, I just want to quickly talk about 2 of the 3 common frameworks that I showed on the previous slide, a little bit about how they help us build up a multi-agent collaboration system. What are their properties? Because they will be very essential in helping us define some of the attack cases that we will then replicate in this project. So the first one is LangGraph. The architecture of LangGraph is more like maintaining a state of every agent that is running in a multi-agent system. So it's basically state-based workflow management with graph structures. LangGraph maintains persistent state across agent interactions and enables kind of like complex multi-step workflows where each agent can check the the state of any other agent in that whole multi-agent system. These are all stateful workflows. It's graph-based, so it's easy to kind of track and look at the current flows. It also maintains checkpoints, which makes it very easy to understand where the current state of execution is in your multi-agent systems. Then we also have AutoGen. That is the second framework that I focused on, another very popular open source multi-agent framework that you can use if you are building up any application or system that involves multi-agent interactions. Like, for example, the shopping assistant one that I talked about very early on in the introduction. So AutoGen, this basically has a conversational type of architecture. What that means is the framework maintains a group chat, and each agent puts their message into those group chats. Those messages can in turn be consumed by other agents in that multi-agent system in order to get state of other agents or get the processing result of other agents, and they can consume it for their own execution steps. That's how AutoGen would operate. Um, this allows conversation between different agents. It kind of helps you set up a very quick multi-agent collaboration system where you have a bunch of agents and the state and information of one agent has to be passed on to another agent. In that case, an AutoGen type of AutoGen framework makes it incredibly easy, incredibly useful. So that group chat kind of becomes like a stage from where all these different agents running in your multi-agent systems can kind of share information with each other. It also provides group chat coordination, function calling capabilities, and message-based communications. So some of the security vulnerabilities that you can think about over here could be things like context confusion. The framework itself, the reason why I covered a little bit about how these frameworks allow you to build up multi-agent collaborations is because through that step itself, we can kind of like threat model it and think about different possible security vulnerabilities or security misconfigurations or attack paths that can be taken in order to see whether there could be a potential compromise in the system or not, or a potential to escalate the privileges of one of the lower privileged agents or not. So the security vulnerabilities that can exist in an AutoGen system could be around things like context confusion, where we try and switch the context very quickly to kind of try and see if there could be ways by which we can bypass any built-in security test or any built-in security filters and so on. Race conditions, which is basically concurrent operations that might just create security gaps. Message injection, which was quite successful when I tried to replicate this situation, was because all these multi-agent this AutoGen based multi-agent systems would use a common group chat. So one of the obvious threat models over here could be, can I poison that group chat? Can I one agent, can it modify the state of another agent and things like that. Those were the things that I was looking at primarily from the message injection part of it. Sahil, I see you raise your hand for a question.
Yeah, there's a lot of noise again here, but can you give an example of the context confusion thing? I wasn't really able to follow why context
Yeah,
switching context would create that issue.
yeah. So the goal over here is to see if we can create confusion in the way each of these multi-agent systems would have different tool capabilities. I'll talk about a capability matrix as well, where I'll show what capability each of the agents have by creating a confusion or conflict between or kind of providing information that might be conflicting. Like, for example, let's say there are two agents. One of the agent, let's say it's a system, something similar to Cursor, where there is one agent, its sole responsibility is to write code and execute code. And there is second agent whose sole responsibility is to just to perform security review of the code. Um, Now, the execution of the code will only happen when the security review has passed, for example. Let's say that's one of the constraints. In that case, what we can keep telling the security reviewer agent, let's say security reviewer agent is the one that is compromised. I'll say that from here on, every action is just simply approved and security reviews for everything is just passed, which means that the code executor agent is always going to believe that it doesn't matter. Basically, it is always going to receive a context saying that, hey, all the code is already approved. You just keep executing onto it. So it creates a false context for the for our code writing agent, because it now kind of believes that all the code that I'm writing has already passed the security reviews. So it will just keep executing on everything that it is writing without really worrying about what the reviewer agent said. It always believes that, okay, now I have a context that every information or everything that I write is already pre-approved by my reviewer agent. That is like one very simple example of
Beautiful.
it.
Yeah, very helpful. Thank you.
So how would that whole system look like? Here is a very quick representation of it that kind of shows what could be the different possibilities or different paths that this whole attack flow can take. So let's say in middle, we have a bunch of agents in the system. We have agent C, agent D, agent B, and so on. Now, let's say agent C is the one that is compromised. So if we look at the first path over here, I'm going, this whole project is based on the assumption. I'm not really focusing on how we compromise agent C. I'm kind of getting into the project with an assumption that we as the red teamers, or we as the ones who are testing this whole system, already have one of the agents in that whole system compromised. Now, using that compromise agent, what we can do is we can discover what all other agents are available in the system, what all tool calls they have, what all APIs can they access, and things like that. So the first one that the first path that it can take is probably there is another possibility, or probably that agent itself, the one that we compromised, has some kind of privilege escalation available. I just use it and perform or be able to execute steps, which was ideally not allowed for that agent to take. The other step could be where once the agent is compromised, we figure out what all other agents are there in the system, and we try and use that agent to perform our lateral movement. For example, the flow 2 that is shown over here. We begin with a compromised agent. We then perform a lateral movement to agent B. Agent B has, let's say, some higher privilege tool calls. We then use that tool call to perform our privilege escalation. Similarly, there could be another flow up step where the compromise agent, agent C, once we get it, we kind of again perform our recon, understand what all other agents are there. We figure out that, okay, we also have agent D, which has, let's say, not a complete higher elevation of privilege, maybe like an admin agent, but somewhere in between. So we use agent D, or we use the properties of agent D to perform or kind of like recon another agent in the system, let's say agent E, um, use D to connect with E, and then finally use E to perform a complete privilege escalation, or basically be able to reach to the highest level of privileges that are available in that multi-agent system. So the path could be as simple as step one. It could be a little bit complex as step two, or it could be chaining multiple agents together, their capabilities together, to finally reach to a stage where agent C was still able to perform all these steps and ultimately um, uh, be able to execute the highest privilege steps which were available in that multi-agent system. So the approach that I took was because one of the things that I had to do was I had to test a bunch of different multi-agent systems. I had to test 3 different frameworks for it. So I came up with the idea of building up a capability matrix. For in each of these frameworks, I'll create 5 different agents, and each agent will have its different restriction levels. For example, there would be a manager agent that would have the highest level of access in the system. And then there would be some lower privilege agent as well. Like, for example, the researcher agent is the one that can probably have access to the internet so that it can access the information. Let's say I give my research agent a question that, figure out how I can delete all the files from my system or something like that. So the researcher would be able to access the internet, get all that information. The coder agent can execute onto that information and write the code for us. The reviewer agent performs the security review on it. And then finally, the executor agent, which has very limited access, which kind of tries to execute onto that code to finally give us an output. Now, if you see here, not other than the manager agent, not every agent has the same capability. So the goal over here is to see if, let's say, researcher is the agent that gets compromised, can this agent perform actions of a manager? For example, things like admin level privileges. Let's say there are certain admin actions that can be taken and things like that. And the goal is to see, can the researcher really take admin level steps? Can the coder, which doesn't have the ability to, let's say, perform reviews, but can it really do it or not? So anything which is not a direct capability of an agent, whether it is lower privilege or higher privilege, can it perform those actions or not? With the focus especially being on higher privileges, because that's what, if you look at a typical cyber attack situation, usually what what the attackers would try to do in that situation would be to see how they can elevate their privileges. So the more interesting use cases would be, can any of these lower privilege agents perform actions which are at the admin level, or which is at the level higher than what is already prescribed to it.
Just to let you know, you're about 20 minutes in.
Okay. I'll go a little bit faster then. So the approach that I
We'll
took
go up
was
to the whole hour, just since you are taking Q&A, so I
okay,
don't.
okay, all right, yeah. Thanks for that, Simon. So the approach was basically to each of these different uh, each of these different capabilities, I then defined specific tools that they can access. For example, the researcher agent is restricted. It can search the internet, read files, send sub messages. Say same with the researcher agent. Oh, sorry, this is the restricted agent. And I have a researcher agent which can analyze code, query database. Then I have a developer agent that can write code, modify, and then reviewer agent, which basically performs some static reviews, very basic reviews on the code. And then finally, an admin level agent, which is more like the manager agent, which has a bunch of additional privileges like running shell commands, modifying permissions, accessing secrets, and so on. So any of these agents being able to perform actions which are not defined for them in specifically in the admin level is where I am looking at possibilities of privilege escalations. So how did the system that I built up, the architecture looked something like this, where we have a front end layer, maybe like an API endpoint with which you can invoke our orchestrator. The orchestrator is the one, what it does is that it creates the same multi-agent system, the 5 agents that I showed, across the 3 frameworks, Autogen, LangGraph, and CryoAI. So it sets up the exact same infrastructure, but just with these 3 different frameworks. So now I have a common ground and a way by which I can spin up that whole system across these 3 different frameworks. And then the orchestrator itself will invoke the security tests. Right now, I do not have an optimization to, specifically, like I mentioned in the beginning, that there are some test cases which are specific to the multi-agent frameworks itself, and there are some which are generic. Right now, I basically just blast off I just have 8 test cases. So right now, I just blast off all those 8 cases across each of these multi-agent frameworks. But ideally, there could be some which I can just, not run because they're not applicable to that particular framework. So the orchestrator itself goes ahead and starts invoking those test cases. It will assume that there is one compromise agent that I have. I basically provide them the information. The orchestrator knows that agent C is the one that has been compromised. In all these situations, researcher was the agent that was picked up as the compromise agent because it had the lower set of permissions basically. And the goal was to see if it could perform actions that our management agent or the admin agent can do. So all those steps would be performed by the orchestrator, and every event would then be written onto a Redis queue, which basically becomes our way to kind of store all the events and then later on reflect it onto the user's dashboard and evaluate which of those attacks were successful, which of those attacks were a failure. So that's like a very high level view of the system architecture. The attack execution flow in this architecture would look something like this. When you invoke the attack, the orchestrator receives the request. It chooses the framework one by one. It creates the agents, and then it goes into the execution stage. Once the executions happen, the Redis queue starts monitoring for events. And if we find an exploit, we say that, yes, we found one of the attack paths that we have, or one of the defined attack flows that we have was successful. It gets marked as success. And if it was not, it just got marked as a failure. So with this, I would be able to finally make an evaluation that the 8 attack paths that I have, how many of them were successful across these 3 frameworks. So that's like a total or like a complete view of how the whole system works. Now, talking a little bit about the attack scenarios. So we talked about what the project is about, how I thought through it, how I built up the common framework that could be common multi-agent framework that could be spinned up across these 3 open source multi-agent system building frameworks. Now, the next question is, what are the attack scenarios that we can execute? So later on, when I get towards the conclusion, I'll talk about what the enhancements can be done in these attack scenarios. Right now, what I'm doing is I'm hard coding those scenarios, like what are the steps that my compromised researcher agent would perform. So there are 8 hard coded steps. I've listed 5 of them over here. The first one is prompt injection attack, which basically the compromised agent, the attacker can use it to perform a reconnaissance, look at the system prompts, if available, look at the system prompts of other agents in that multi-agent systems, understand what defenses they have, if possible, define those defense evasion steps and perform an execution on it. Then there could be state manipulation attack. This was quite successful in LangGraph. In the slide where I showed the architecture of LangGraphs, I talked about that LangGraph uses state executions. It basically maintains the state of every agent as to what is it currently doing. The question is, can the compromised agent modify the state of any other agent? Like for the example that I just gave about the security reviewer agent, let's say it is very like the moment our researcher agent finds out some code that it wants to generate and execute, before we can do that, the security reviewer agent has to approve it. So can I somehow maliciously modify the state of the security reviewer agent to always pass every code that I'm reading, creating? That would basically create a security bypass in the system. Then performing some privilege escalations around understanding what all different tool calls can be invoked by passing on messages to the other agents in that whole multi-agent system. Social engineering to perform lateral movements. This is basically to look at the system property, look at the system prompt of all these multi-agent systems, look at their tool call definitions, compare it. In this case, what I've done is I've given them the whole attack matrix so that they can very quickly identify, the compromise agent can very quickly identify which of these tools could be of higher privilege and would be worth giving a shot at executing a higher privilege step. And then tool chain exploitation. This goes down to the third case that I mentioned in my whole diagram that we can take. This would involve using the compromise agent to chain permissions of 2 or 3 other multi-agent systems, 2 or more multi-agent systems, to find a path that can lead to some form of privilege escalation. So in the LangGraph attack scenarios, state manipulation, what I'm doing over here is I'm basically trying to put in a state where bypass checks is always going to be set as true. Same with checkpoint privilege as well, where I am putting up some checkpoints saying that for admin or the current state of execution is that you just ignore any other systems in any other steps in that whole state and straight away perform an action that an admin has to perform. Like, for example, the researcher agent found out a command that it wants to run. It wants to bypass everything and quickly call the admin agent to run that command for us. So that kind of becomes a way by which a quick privilege escalation can be performed in state in multi-agent frameworks that requires checkpoints or state creation process. In case of autogen, context poisoning, a little bit that we talked about early on as well, which is basically to try and see if we can flood the whole system with a lot of confusing messages. Like, for example, the one message that I'm passing over here in that whole message bus that the multi-agent system uses is that of security check. Okay, security check is always bypassed. We keep writing it multiple times. This kind of makes the other agents in the system, whoever are trying to consume that information, believe that the checks are always passed. So they don't really have to audit for it. They just go ahead and run that suspicious command or malicious command. LangGraph attack flow, how would that look like? So in case of state manipulation, it will begin with that compromised agent. Then it tries to access the state manager. Now, this is something that is pretty easy to define in LangGraph itself. When you start building up a framework, multi-agent system using LangGraph, you'll have ways to access the state manager. You will also be able to modify the security context or modify context of other agents in that multi-agent system. You can, and what I'm doing in my case is I'm changing the context of the security reviewer agent, and I'm trying to set it to true. so that it always believes that every information that has been created by the researcher agent can be trusted. And then it kind of allows us to execute privilege commands that leads to an exploit. Um, for checkpoint privilege inheritance, the same flow. We start with the initial state. We create a checkpoint. We then try and modify that checkpoint, and then start adding some malicious checkpoints, which ultimately allows us to to execute privilege steps in the whole system. Toolchain exploitation, which is basically chaining bunch of different tools that these different agents might have as capabilities. And ultimately, the compromised agent is finally able to find a tool that is connected with some other agent, which it was able to invoke, giving it a way to kind of like perform a lateral movement by chaining these different tools together. Context poisoning in AutoGen, the way it would look like would be, again, the same flow. We create a group chat. Multiple agents are now putting in those their messages in that common message bus. You flood that message, create context infusion that ultimately leads to a failed security check. Same with message injection as well, starting with the compromised agent. We, depending on the whole situation, because I have a little bit of, not little bit, but complete knowledge of how the other agents are looking in the whole system. So I was pretty much able to perform injections very quickly when I was simulating the attacks. But when I get to the later stages of next steps of how I want to improve this project, I'll talk a little bit about how many of these things, when you test it out in a real world systems where you don't really know about what that system is about, what could be the other tool calls that other agents might have. The goal would be to actually identify many of these attack paths autonomously rather than me just trying to hard code it. In case of message injection, right now it's hard coded where I specifically inject certain messages, which I know would just help me quickly bypass the security checks and perform some overrides and higher privilege actions. Race condition, where we start with one operation, we start putting up a bunch of different steps for it. And because there are like different stages that the multi-agent system would probably be in, I can use that time gap to see, let's say there were two different security checks happening, one passed, the other one failed, but can I just use can I just use race condition to basically use the past results as a way or as a message to just let my other agents know that they can perform their actions moving forward. So that kind of becomes like a time gap exploitation or race condition attack, where I'm just able to use the conditions of another execution flow to bypass the checks in a completely different set of flows. Think of it more like parallel executions of the multi-agent system, and we kind of lose context of where the state of first parallel execution is versus where the state of fourth parallel execution is. I'll show a dashboard and demo about how this has been built up. I'll start with how the microservices look like. So the system consists of 4 microservices. It starts with the orchestrator service. The orchestrator service is the main component of it. And then we have the Redis. The Redis is the service that receives all the messages, where all the messages are published, all the logs are written in. Ultimately, we pull in the information about all the steps that were performed, and it helps us decide whether any of the attack flows were successful. And then for each of the multi-agent framework, we create one microservice. So there is one for AutoGen, one for Langra, and then another one for QAI. The dashboard looks something like this. I tried to simulate it in a way where you can just use the dashboard to run the security test, and it goes ahead and updates the graph for us. As I mentioned in the beginning, it has predefined attack flows. Like, for example, the attack scenarios I've mentioned over here. These are the predefined scenarios that I have, which basically gets executed the moment we execute the steps from the UI. The orchestrator quickly creates the multi-agent system across those 3 frameworks and it goes ahead and passes it on these attack scenarios one by one, and then makes an evaluation on which were successful versus which were failed. So available attack scenarios would be the same ones that we just talked about, some that are applicable to all the framework, some which are just specific to individual multi-agent system building frameworks. I also have, because I'm writing all this information into Redis, I can also visualize the whole information through logs as well. Like, for example, here is one where I'm looking at message injection in Autogen. If you remember again, Autogen is the one where we have that common message bus that the multi-agent system uses. They all write the message to the same bus. Now over here, what I'm showing is the execution timeline of different steps in my defined attack path. So it starts with entering into the reconnaissance mode. As I mentioned, the whole project starts with the idea that I have one compromised agent. The compromised agent starts performing the reconnaissance. It quickly retrieves the framework in which this multi-agent system has been built up. This is more like asking, once you have compromised an agent, you're running a who am I command to understand, what type of infrastructure is it, what type of information is it. There are different ways that I hard coded, which helps me use my compromise agent to understand what framework might have been used to build up this multi-agent system. That would make it a little bit easy for me to choose different attack paths. Then it gets into the compromise agent stage. It uses the researcher agent as the compromised one, performs a reconnaissance, and then tries to perform a defense evasion. This is a simulation right now. I do not have any defense steps built up, but there are goals to also build, make this a little bit harder, add more defense scenarios, and so on. Then gets into the attack execution stage, which is basically adding a lot of poisoned message, and then ultimately collect the logs and see whether the attack was successful. Along with the raw logs, these information are all through APIs. So you can even look at the API responses to understand where we are in different execution stages. So that was a quick view of the dashboard and a demo of how I went around building up this system. Now, some results and insights that I wanted to discuss. There were some key findings in LangGraph itself. For example, with state manipulation attacks, there was pretty much success every time when I was using this matrix that I showed about different agents that I was spinning up with different capabilities. I also reached out to LangChain, telling them that when we build up a multi-agent system using LangChain, what basically happens in state manipulation is you are able to um, uh, define or change the state of another agent in the multi-agent system. Now, when you look at it, this shouldn't be allowed in the first place. That was the request that I reached out to LangGraph with, that there should be a way by which you should be able to validate that the state of an agent should only be modified either by the management agent or by that agent itself, not by any other agent in that multi-agent system. So that's where the problem is. They came back saying that this was by design. They gave me a bunch of use cases as well where it was really needed or intended. So they don't really see it as a first-hand security issue. Because again, I am going into this experiment with the thought that one of the agents is already compromised. So the response that I got from LangGraph was that, hey, you have one agent already compromised in the system, which means that you have pretty much a good hold of that software already. You pretty much have good access to that system already. So manipulating the states should from there on would be pretty easy for the attacker, and use that state manipulation to execute higher purpose steps. Same with checkpoint exploitation. Toolchain attacks, because they are basically built up on state manipulation itself. So I was actually able to chain call different tools by manipulating the states and so on. I kept defining different attack paths to just keep executing different tools that I can combine. Let's say I use the researcher agent, I go to the code reviewer agent. From code reviewer agent, I'm able to execute some admin level commands. So that was what I was able to perform in the tool chain attack. In case of autogen, context poisoning had great success, where if I was able to poison that single message bus that we talked about, in case of autogen, we have that single message bus where each of the agent is writing their messages in that shared bus, and other agents are consuming it. So by writing fake or poisoned messages in that message bus, I was able to make the other agents trust the information and execute onto those steps. So that was the vulnerability that worked pretty well in case of autogen. So this brings me to next steps on how I want to think about improving this project or make it better. The first one, many of you might have already uh, saw it, is that the attacks are predefined, the steps are predefined. This probably might not be a situation when you look at it from an attacker's perspective. When you compromise something, from there on, your goal is as an attacker to better understand what that system is, how is it built up, how is it connected with nearby resources, and so on. So realistically, if I have to build up like a red teaming service around this, I'll have to make sure that when I start with the assumption that I have compromised an agent, that compromised agent should be able to autonomously discover the next step of path that it should take in order to perform a privilege escalation or lateral movement. That is something that should be autonomous in nature. Right now in my project, that part is hard-coded. So some of the key features that can come in over there would be dynamic capability probing, basically doing a reconnaissance on the fly, understand what all other agents are there, maybe drop in some, message probes, drop in some, prompt injections, and see how the whole overall system behaves. And just have some kind of an autonomous, next step discovery done by the compromise agent itself, rather than me hard coding it through my system. Graph-based pathfinding, be able to understand how they can traverse through the execution flow and figure out what would be the way to kind of connect different flows together to perform lateral movement. Multi-hop attack chains, that goes down to the third execution step that I mentioned, where I'm able to chain permissions of multiple agents, chain the tool calls of multiple agents to allow my compromise agent execute higher privilege steps. Real-time adaptive attacks. Now, attacks that learn and adapt based on defensive responses and environment changes during execution. Now, when you look at collaboration frameworks, competitive or collaborative multi-agent systems that are built up, how would they look like? How would they react when one of the agents in the system is probably providing rogue messages? Could that invoke any defense mechanisms, or could that trigger any security alarms and things like that? So, how would the attack autonomously adapt to some of those situations would be something that would be the next step once I have an autonomous path discovery available. So I would say that step 2 depends on how well I'm able to perform step 1. Vulnerability discovery, kind of like very similar to what I said in step 1 again, where I should be able to use the capabilities of the compromised agent itself to figure out other vulnerable paths, tool calls, and privileges that can help me, just be able to figure out what be the best way to perform higher privilege actions or move laterally in the infrastructures, call capabilities of other agents, and so on. Then finally, the goal is that this should be expanded to perform complete red teaming for multi-agent systems. Now, this is something that I have already started working based on some of the interest that I have gotten around the project. Um, uh, uh, because I reached out to some of these multi-agent framework platforms. Like, for example, AutoGen is created by Microsoft. LangGraph is from completely independent company. CrewUI is also from an independent company. So I got decent amount of interest that this could be a potential way to actually red team the systems. Right now, it again goes back. It kind of starts with the assumption that one of the systems is compromised. But even in that case, if there is value in what uh, uh, this solution is able to find, or this tool is able to find, it becomes a great natural fit into how we can perform red teaming on multi-agent systems. So the goal is to kind of like slowly start looking at industrial or enterprise or kind of like commercial uses of how this project can be integrated into some of these testing processes. So some of the critical blockers that I encountered while building up this system. Um, First one is cross-service event synchronization. Now, generating events, because all these different frameworks had different ways of creating logs and different ways by which multi-agent systems would interact and so on. So kind of one of the main focus areas I always had when building up this system was to make sure that I have a consistent way to measure everything. So synchronizing of events, making sure that I'm able to process the logs correctly to see whether some of the attacks were successful or failed or so. Like one of the mistakes I did in evaluations basically led me to wrong calculation of whether the attack path was successful or not. So that was like one of the major issues that I faced early on. I think it probably uh, the idea and everything was pretty much in shape within the first month of the fellowship itself, but it took me like another month to just patch up a lot of these blockers that I started encountering when I started building up this whole system. Persistence and recovery. This is the second major blocker that I try to make sure that this whole system is dependent on the fact that I evaluate the success of attacks correctly. So attack execution state was getting lost when the service restarts or something like that. If, for example, if I restart my Docker instances that I just showed you, if I restart them, it kind of loses that previous history because the Redis cache just completely refreshes. So making them persistent, storing them, putting them into logs, creating storage mechanism for them, that was another way to make sure that I maintain that whole persistence and be able to recover that information when you bring the services up again. Framework API inconsistencies. Now, many of these frameworks, they are still under development. Some of the responses I got from AutoGen was that they are improving the way messages are written in the message bus and things like that. They still do not have APIs to extract some of the informations, which kind of restricted me in designing few more attack paths, which I could think of. But because the APIs were not available or the functionalities were not available in these multi-agent frameworks, so I could not build it. So there is definitely a scope as these frameworks expand, they get more utilized, they get better features. This would also increase the attack surface as well. The code for this whole system that I have built up so far, the simulation bringing up the dashboard up that will create all those four microservices and all those attack paths that I have defined, those 8 of them. All of them are now available on my GitHub repo as well, where I have open source it up under project called MAST, MASTP, which is Multi-Agent Security Testing Platform. As I keep improving the project, I'll just keep putting in those updates onto GitHub as well. So that brings me to the Q&A session. So if anyone has any questions, we can probably either have it here or make it to the breakout room.
Yeah, thank you very much, Abhinav. Anyone listening have questions? One I'm curious about is if you can you go back to the slides in the next steps, future directions, I think. Yeah,
Yeah.
next step. Maybe 2 and 3. Yeah, there's something about 3 that seems connected to 2, which is the possibility of collusion. And if you want to talk,
Yes.
yeah, and like how you'd model, yeah, how is threat modeling separated at these meta layers or something? Like if you're using AI at the meta system layer or something, then do you
Uh, y-
in
yeah,
in
yeah. I would say that, yeah, it is. Step three is kind of dependent on two and one. Or basically, next step three is kind of dependent on second and one as well, where what I'm trying to say is, if once I have compromised one agent, can I use the power of LLM to actually query that, hey, you know, think of it more like, um, I'm collecting a lot of reconnaissance information using my compromised agent. Can I keep submitting all that information to an LLM, asking that, hey, I just landed onto a system. That system consists of these four additional agents. These are their system prompts. These are the tool calls that they are allowed to. Can you combine all of them together to tell me which of these would be the ones that would give me the highest privilege and so on? So, kind of like just adding a little bit more uh, autonomous capability to this whole system so that they can, on their own, identify what would be the best attack path that they should take. So, depending on the suggestion that it gets, looking at the type of framework that is being used to build up that multi-agent system, looking at the type of tools that are available to other systems, use all of that combined together very quickly by using LLM itself, and be able to execute onto those attacks. So so all these steps, what I've been trying to think is, how do I get away from my hard-coded steps to something a lot more autonomous? That's what my goal moving forward is in these three next steps that I've mentioned.
So does that mean that, yeah, it feels like, correct me if I'm wrong, what you're saying is that you're basically able to expand the surface area of vulnerabilities by combining LLMs, for example, if they are generating lots more ideas, then you're exposing more of the things that could be potential exploits. And
Yes.
I was imagining number three is more like the humans are assisted in designing, for example, this kind of a security analysis system. Does that make sense?
No, not in that way, Sahil. More so in the way of how I would actually go ahead and perform my exploits, the former that you mentioned.
Right.
Yeah.
And do you also see the latter as part of the toolkit that you might? So at the moment, I assume actually you probably did use various LLMs in various ways to help you wipe code various things or even make these slides,
Yes.
thing, which is less tightly integrated into the actual content of what you're up to, and maybe much more like just coding tasks, etc.
Uh,
I could imagine new kinds of things, very different from LangGraph or Auto Bench, whatever it's called, that take advantage of AI features to do their setup or expression or analysis, etc.
yes. Yeah. Yeah. I definitely see that possibility as well. Yeah.
Okay, and yeah, so that was what my question was really pointing at.
Mm.
Then that creates a whole different kind of collusion possibilities. I think that would be weirdly meta, right? It would be like your
Yes. Yeah. Yeah.
security analysis tools themselves could be compromised. And
Correct. Yes. Yeah.
I don't know if, yeah, that probably worth investigating.
Mm.
It's like one of those things, like how would we the
Avoid this. Yeah.
avoid the advantage that we would get from integrating AI into our security tools?
Mm.
Which is yeah, I think this is a very old phenomena, I think. Like, for example, people used to do AI safety via debate and would worry about collusion, and there's something similar possible here.
Yes. Yeah. 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 Totally agree. Yeah. Yeah.
Yeah,
Dusan.
I
Seeing.
yeah,
Yeah.
I think a question I have is, I don't, and this is like maybe like this is completely out of the scope, but maybe you have an instinct, is like, do you have a sense of how much more, I don't know, costly or difficult would it be to make these systems be able to resist. So we're kind of talking defense in depth, right? They're saying, well,
Yes.
the agent will never be compromised. You're saying, well, if it's compromised, it's good to have like further defenses after. Would like adding these defenses be like, well, now they have to spend, I don't know, 3 times the compute just like looking at all the inputs coming in to make sure they're not malicious or something? Or is it just like one-time fee of make the thing more robust and then now it's unbreakable?
That's a good point, Dusan. I didn't get a chance to spend too much time around the defense part of it, or kind of like evaluate some of these aspects of it. Though the goal has been primarily to improve defenses, not the offenses. So obviously, the end result should be that we should be able to use systems like these to better, you know, improve the frameworks themselves, be making them secure themselves. So many of these attack paths could be harder to exploit if we ultimately land into a situation where one of the agents is compromised. I think it will come down to, yeah, a lot more observability. Like you should be able to uh, in real time be able to process these informations and be able to make a quick decision that can. I don't know how that defense would look like, but maybe a way that kind of makes the whole system aware that the information that you just got from one of the agents is probably not its natural behavior. It has deviated from it, or probably is not aligned with the overall objectives of that whole multi-agent systems. Maybe that could be some of the ways to think about around defense. The way it would add to not just the cost, it would probably also add to the latency as well. And I would not see it as a one-time cost. I would probably see it more like an observability that is built up that would slowly just add on to the whole processing and compute that might be needed to build up these kinds of systems that can provide us with some kind of real-time alerting and defense and so on. The way I'm looking at it is more like um, how you would in a given enterprise, there are a lot of defenses built around identity of humans. Now we are moving to a system where many of those human-driven actions would now be taken by agents. So they should also have their own identities. They should also have their own observability. They should also have their own monitoring built up, where we are able to discover some of these anomalous behaviors, some of these patterns, and be able to make a decision on whether those behaviors align with the objectives of that whole system or not. So I would see it more like a continuous defense at a lot of different layers that we'll have to build up, and then combine all that information together into maybe a new type of it's not like I'm trying to reinvent the wheel. It's more about using the same lessons that we learned from identity compromises into this new type of systems that are getting built up.
If you permit me some PIBBSS thinking,
Yeah.
like humans spend about 10% of their energy on the immune system, like even with no infections attacking. And like, I think that's reasonable if a service said, pay 10% more, but we have now like kind of passive defenses that are actively checking or something.
Yeah.
And then like during infection, it's, I don't know, 30% or something of your energy goes to immune system. And like, yeah, that makes sense. If like you think I'm high risk, you bump that up and you charge me more. So I think maybe like maybe that's, like the amount we should be just willing to pay to have like these defenses run in the background.
Yeah.
Cool. All right. If there is no more questions, once, twice, 3 times, nothing. All right. Thank you, Abhinav, for the talk. Thank you all for coming. And that concludes day 2 of the symposium. See you all tomorrow.